Thanks for watching the screencast. The objective for the screencast is learners will be able to convert an expression between rational exponent form and radical form. So here is the definition of a rational exponent. Remember that rational essentially means fractional. So rational essentially means exponents that are fractions. So if you have x to the a over n power, that is equivalent to the nth root of x to the a. And I'll give you a couple of specific examples here. If I gave you the square root, you know we don't usually write the index for a square root, but it's the second root. If I gave you the square root of x, well, that's another way of saying, since it's x to the first, that's x to the 1/2 power. Here's another example. If I gave you the fourth root of x squared, I would say that's the same as x to the 2/4 power. One more example. The cubed root of a plus b to the 8th would be a plus b, that quantity, that thing, to the 8/3 power. I can give you a quick intuitive reason behind why this definition has to be true. If I think about, I'll rewrite this here, but if I think about the fact that the square root of x really means the same thing as x to the 1/2 power, if I thought about squaring both sides of this equation, that's a legal equation move. You can square both sides of an equation. And what I hope you're going to see is that both sides of this equation say x to the 1st power. The square root of x squared would be x. And then the rule for multiplying exponents, or I shouldn't say multiplying exponents rather, but raising something that has a power to another power is to multiply the exponents. So x to the 1/2 power squared should be x to the 1st, or x. They're equal. The goal for this screencast is to be able to convert between those two, so we should practice both directions. Here's an expression that's in what we call radical form, and we'd like to write that in exponential form. This is the 5th root of x cubed, which can be written as x to the, the power for the radicand goes as the numerator, and the index is the denominator. That's x to the 3/5 power. Here is the other direction. This is a expression that is in fractional exponent form, rational exponent form, that we want to write in radical form. We want to write the answer with a radical. It might help to remember that if you've got a negative exponent, that's the same as 1 over the same base to the positive exponent power. That's something that was true even in previous studies of negative exponents. So n to the negative 1/4 power is 1 over n to the 1/4 power. And I can write the n to the 1/4 power using the definition of the radical for a fractional exponent. So this expression is 1 over. This would be the 4th root of n to the 1st power, just the 4th root of n. And we're there. Okay, it's your turn to try. Take a crack at these. Hit pause. See if you can perform these two tasks, and when you've got answers that you like, hit play and we'll check it out. The cubed root of 2x plus 1 squared would be the same as 2x plus 1 to the power of, 2 over 3, 2/3. The power of the thing in the radicand is the numerator. The index is the denominator. Can we go the other direction? Sure. I can write the quantity 5a to the 7/4 power as the 4th root of the quantity 5a to the 7th power. Thanks for watching.